on to 5:30. So we're going to be doing our second lecture on Excel today. In particular, we're going to be diving deep into doing some data analysis. So this is particularly interesting for us as data scientists because the first lecture was mostly about where things are, how to find them, how to use some of the functionality. But we'll try and do some data analysis stuff today. So you kind of get a feel for what business intelligence and data scientists do with Excel. All right, so first of all, the many people still use spreadsheets for data management, and spreadsheets are used to store data, and we'll talk about a little bit of how data is stored sort of globally in some of our database lectures and later on. But at the moment, what we are currently talking about is oh, I hear someone talking. Okay, so what we're currently talking about in terms of databases are something like schedules and calendars, timesheets, most commonly expenses and finance, records, registration records, personal records, things like that, and also data research and data analysis. For instance, you might want to do an analysis on the number of the number of salaried jobs between male and female and what the split is. Just this morning, there was an article out about how there's still a gender gap at all of the institutions, the higher education institutions in Canada, UBC included. There's a wage gap still, even though they've tried to take steps to sort of reduce that. The wage gap still exists, and I'll probably post a link to this in the Slack after this, just so you can have a read. But things like that are, sometimes those data analysis are done in Excel, and so we need to know some of the functionalities of how to store data. Okay, so store and sort data. So just in the previous slide, we talked about, we should have talked also about sorting and filtering. So you don't just want to view all your data at any given time. You want to sort and filter it. And so we'll first talk about sorting. So data can be sorted by selecting the sort option under the data menu. So on here, again, things might be different for you depending on the particular version of Excel that you have. But here we've got our Excel spreadsheet. We would typically select the columns that we want to sort or filter, and then we would click on the data menu here. Put my cursor on. So you select the data that you want to sort, click the data, and then the sort button here, that will let you bring up this box that asks you how you want to sort. So it'll put all the category names there. You can sort on values, the color, the font, icon, as well as the order. So A to Z is ascending, so it goes A, B, C, D, all the way up to Z, and descending is Z to A. Right, so that's typically how you would filter. And then if you want to add multiple sort conditions, so let's say first I want to filter by month. I'm going to sort it on the value of that month, and I'm going to go from A to Z. And then I'm going to sort by the cost, let's say, and I'm going to sort by largest to smallest. And so when I click this, what you'll notice is that it'll sort by the letter of the month because it's alphabetical. F comes before J, even though January comes before February. But numerically, Excel does a pretty good job, obviously, of sorting by the cost. So if there's 2 Februaries or 3 Februaries, it'll pick, depending on if it's ascending or descending, it'll pick the highest cost first and then go down. So that's how you sort. So what we will do now is just to sort the data by revenue, and then the product. So again, if you, one more time, if you click the data button here and then sort, you'll get a little box. You can sort by revenue, and then you can add another add another sort condition to do it by product. Okay. So there you go, there's your sort, and that's how you sort in Excel. If you want to filter, let's say you only want to see a particular month. Let's say you only want to see January. well, you could go ahead and delete certain cells. So let's say I would delete everything from here to here because all I want to see is January. So that is an option, but generally speaking, you don't want to delete your data. You want to keep it because at different times you'll want to look at different things. So in that condition, in that case, you want to use the filter button here. So it's right beside the sort. Click the filter button, and then you can, these little drop downs will appear in front of each of your columns. So then when I click on this drop down for the month, I can uncheck them all by clicking select all. And then when I click January, you'll notice that only the January entries are showing. All right, so that is that's filtering in Excel. And then again, once you click select all again, all of them will come back. One key thing is that you should note that these colors will turn blue now to indicate that there are some gaps, and there's going to be a solid line here showing you that there's entries missing between the first row and the fourth row, which makes sense, but it's nice to have a visual cue that, hey, look, pay attention, something's missing from here, from the view that you're currently looking. There's also the auto filter function, which you can explore and see how that works. It's obviously possible to filter on more than one column at the same time, just by checking that filter button. So let's do an example of that. So how to filter multiple times. So we'll do filter on the revenue. So we'll click here, we'll sort ascending first. So this is actually another way of sorting. You can also use the filter feature to sort. Okay, let's just select everything. So we'll sort. To do this, all the merged cells need to be the same size. I don't understand what that means. All the merged cells are the same size. Oh, I see. Okay, so I think it's because there is still a filter situation happening, which I've now removed. I don't even know why this would be happening. Okay, well.
Is it because of the total?
I'm not selecting the total though. I'm just selecting this.
You may have created the filter while selecting just
this
a bit
one.
of the.
Here we go. Here we go. Here we go. This is it. So this particular, you're right. It is because of the total. So this this total button here is actually a merge cell that combines column E and F. So what I'm going to do is I'm just going to move this here temporarily, just to kind of show you that this indeed does work. And then when I try to sort ascending, this will work. Okay. So the reason that didn't work is because it was trying to sort the entire table, but there was a particular cell here that was merged. And Excel obviously doesn't know how to sort a merged field because this takes over 2 columns. And so it doesn't do by F, doesn't do by E, it's an ambiguous situation, so it doesn't actually do anything and it gives an error. So that's actually a very helpful error, and thank you whoever noticed that to let me know that it was a total column that was giving issues. Okay, so that's that. That's how you filter and sort. There's various other functionalities in filter that I encourage you to look through. You can do top 10, bottom 10, average, greater than certain amounts, fewer than certain amounts, and things like that. Yes, you have a question, Thompson? Go ahead.
I just wanted to note that if people want to do something like that, like sort, but they have merged cells, you can just highlight whatever area you care to sort and define it as a table. And then you can still get all of those sort functions, but limited to a certain range of cells.
That's right. So I think I don't usually do that because there's some disadvantages to that, but let's see how I can turn this into a table. I think if I click the table button, where is this? Format. It's a leaf blower outside my window now. Okay, help me out here. How do I turn this into a table?
If you go to home.
Yeah.
And then there should be a button there for set as a table or format as a table.
Format as table? Okay, right. Yeah, there we go. first have to remove filters and then, okay, so anyway, you get the idea. There's currently a filter in place, so I have to first remove that filter, define it as a table, and then I can sort and filter with merge cells. Thank you for that tip. That's useful. All right, let's keep going. So we can also set a custom filter on the in this example. I just showed you this, you could set a custom filter with your own formula, and that's also possible in Excel. Okay, so this is just a result of that custom filter. This is an exercise that you're encouraged to try on your own. It's just going to give you the result that I've shown here. Once you add the filter with the revenue of 150, the lowest revenue that'll show is 300, or sorry, 200. They must have set that to 200, not 150 here, because 200 should be showing. Oh, there's 200. Okay, so right, so this is incorrect. If you set the revenue to be greater than 150, you will see that the lowest number that's present is 200. And the reason I got confused is because it wasn't sorted, and it looked like it was descending, but not that. And then you can filter on values that are greater than or less than. Again, same idea. Let's say you want to get the volume to be one column to be with a volume of less than 50, and the revenue to be less than 100. You can do that as well. Great. So the things get a little bit interesting when you use the OR. So you can filter the data, as I said, with the volume less than 20, or with the revenue less than 65. So when you do things like that, I just urge you to be really careful in how you create those filters, because you may have a very good reason for doing this at this particular time, but there's no real way to document what your filters are set. And so, when you come back to it, an hour or two later, you might get really confused about what kind of filters you're setting. And so you'll just want to be frustrated and clear the filters and start over. So I just urge you to, maybe make some notes somewhere else. Maybe some people here have some best practices on their work in the industry, on how they use Excel to document what they're doing. If this was, another Microsoft Office app, I'd suggest something like presenter notes or speaker notes, where you can just write quick notes on what you did to get to the current view before you save it and send it. Maybe email is the best way to do that. I'm not quite sure, but just be careful how you work with filters. You can do all sorts of things, like in this example, set the volume to be less than 20 and the revenue to be less than 65. Okay, so another useful functionality of Excel is the data cleaning. So whenever you get a new data set, you'll first want to investigate and see what type of data there is. Are there any errors in it, missing values, any duplicates? And then you want to take care of those separately. So to remove duplicates, select your data. Let's say I'm going to select my data. Click on again, the data button again. And then there's a remove duplicates. So let's see what happens when I click this. I'm going to say okay, so first I'm actually going to select my entire table, remove duplicates, and then I'm going to tell it which column to select duplicates from. So again, if I select column C, that is my number, my months. So if I, let's see, I do just column C, and I remove the duplicates, what it's going to do is remove all of them. That 8 duplicate values were found and removed, 3 remain. Okay, so this is really bad, as you can imagine. It has now removed my data wherever it's at January, okay? Because, sometimes January, there's 3 instances of January, and they've removed, I'm not sure what the order is, perhaps randomly removed 2 of those 3. So you want to be careful how you use this remove duplicates function. And obviously, first thing you do is click this here. Usually you want to remove duplicates only based on a particular index. So let's say there's a customer number or there's an item number or something like that. And then you can make sure that you only select the useful column that you want to remove duplicates from. All right, let's do a quick clicker question just to review sorting. I've got here a poll that I'm going to open up for you about given this current spreadsheet and the sort order, what is the output of this? So we've got numbers 111, 222, 33, and then the characters A, B, etc. And so what I want you to see is what is the output when I sort by number on values, largest to smallest, and then I sort by character on values, largest to A to Z. Right, it seems like the C's have it. So while this is happening, I will quickly do this demo. So I've pasted the numbers in here, I've typed them out. So I click sort. First thing I want to do is sort by the column number, and I want to switch this to largest to smallest. And then I want to sort by character, and then I want to go A to Z there. And then I click OK. And there you have it. C is indeed the correct answer. So this is probably not going to be like a quiz question. Don't worry. However, this is kind of gets you in. This should get you thinking about the decisions that are made behind the scenes that you're not aware of when you click buttons. So when you click that sort button and you set the threshold and you know the order or the ascending descending as you like, you have a certain expectation that something's going to happen. So for me, I got tricked by this question as well when I first looked at it. And the reason that I expect certain things to happen is because in my mind, I have decided that little a is going to come before big A. Okay, so that is something that I've decided in my mind, or vice versa. Let's say in your mind you have capital A all the way to capital Z, and then little a all the way to little z. So in your mind, you've decided that there's an order to these things. However, that's not necessarily the same order that Excel, for instance, has decided it's going to use. So by default, the sorting is case insensitive. So first it takes the letter, you know, whether it's capital or lowercase, it's going to take the first letter that it sees, small a, then do big A. And then it switches to big A because the number here goes to 2. So you can see here that in this particular case, big A comes before little a. So the case doesn't actually matter in here, the case of the letters. So hopefully this is illustrative to you. In Python, this is done differently, and sorry, Python and R, this is done differently. And again, I'll go back to the Zen of Python. If you type import this in a Python console, you'll get a list of you know conditions that it sort of Python abides by in general, or should abide by. And one of those is that you know it's better to be explicit than implicit. And one of the other ones is in the whenever you have a situation, refuse the temptation to guess. And this is exactly what we did here. We guessed what would happen. Behind the scenes, there are values, and I see that in the chat, ASCII values, exactly. So each of those have a particular value associated with them, and there is a natural ordering that is there. However, in Excel, that ordering is not respected, and it's case insensitive. I'm not sure why that is. Perhaps it's historical. Perhaps it's because the tool that this program was made for, they didn't care about things like ASCII values, and they had messy data to come in, and it didn't matter to them whether it was capital A or little a. But that's just kind of it's there. It's kind of probably never going to change, and that's just something you have to be aware of when you're doing these kind of analysis. And usually, I would just suggest an energy to check whenever something like this comes up. Any questions about that? Feel free to raise your hand. Okay. Right, let's keep going. So we now have a filtering question. So let's look at the spreadsheet here and then answer some questions. We have a spreadsheet with that has numbers on column A and letters in column B, and 1, 2, 3, 4, 5, A, B, C, D, E. So what I want you to answer is not how many, but which of these statements. So which of these statements are true? The first one is the data is sorted ascending by number. The filter number greater than 3 shows 3 rows. The filtered letter greater than equal to C shows 3 rows. The filtered number is less than 3. This is one condition. Or the letter is less than B, shows 5 rows. So this is a starting spreadsheet. This particular case is the current state, and each of those other ones are things that you would do to the data. So after you filter it, how many rows would you see, for instance? Go ahead and answer that question once you are ready. That for filter, there was only a greater than. For filtered letter, there was greater than or equal to, and so that'll change. And then number 4, filter number, what do you think?
I said true because less than 3 covers the first 2 and greater than B covers the rest of the 3 of them. So it's 5 rows.
Perfect. I think you guys all got that right. So 1, 3, and 4 are correct. 2 is not correct. Good. Let's keep on moving on. Thank you, everybody. All right, so let's talk a little bit about charts. So you're gonna learn more about how to create charts or visualizations or plots in one of the later courses, I think in January. It's one of my favorite courses to teach. I love teaching visualization and data communication. So we'll be talking about a couple of new libraries to do that. But at the moment, we want to make charts in Excel. It's kind of a very nice way to make charts, and we'll talk about through some of the nice ways that you can do spark lines and things like that in Excel. So a chart is a graphical representation of data, and then there's different types. You can have line plots, bar plots, histograms, all sorts of different plots. And usually you want to, in Excel, format or create the data or wrangle the data in a way that the chart is ready to receive. For instance, if you want to build a histogram, unless you have the analysis tool pack, you need to create the bins yourself and then put the numbers in the bins using various other formulas. All right, let's get on to charts. How you would do this is you look for this insert button and then you can click charts. So you'll get a bunch of charts. There's various cool ways that you can format the charts, and this has gotten a lot better over time. This used to be not a very useful way of plotting data. Especially the recommended charts. Sometimes it'll try and look at your data, look at the columns, and then try and guess at what type of chart you're trying to create. So that feature has definitely gotten a lot better over time. I would just always just ignore 3D. Do not make 3D plots. I don't want to see any of those in the labs for this course or any other course. Do not do 3D plots. Okay, so chart tools, this menu here lets you change your axis titles. You want to have axis labels on the X and Y axis. So those are important, and you can access that with chart tools. This is a useful button. Sometimes you just want to switch the order of your X and Y. And so you want to make your headings horizontal so that people can read it easier. This button here switches the rows and columns, so you can do that. All right, trend lines are very useful. Let's say you want to add a line of best fit to your data. You can certainly do that by right-clicking the data points and then adding a trend line. And there's various options you can use: exponential, linear, logarithmic, polynomial, power, moving averages. And you can play around with those different settings there. For instance, what the order is of the polynomials, also for the moving average, how long you want that window to be where it takes that average. So those are all useful features of the add trend line. I used to do this a lot in high school and a little bit in university as well. But eventually I did move all of my data analysis to first MATLAB actually, and then to Python. So we can create a chart that makes it easy to see the best-selling product in every month. So we've now created buckets. So this is for January, this is for February, and this is for March. We can see easily which one has the highest amount of revenue. So it's jackets in January and February, and in March it's bats. People go outside and play baseball. Spark lines. Okay, so I want to spend a little bit of time on spark lines. That's really, it's kind of a, I think it's new to me because I never did this stuff in Excel, but now that I see it, I can definitely see the value of something like this. So if we go to one of our data sets, we can create a spark line chart, which is essentially just a visualization with no axis labels or anything like that, just showing you the trend. So here I've got it kind of going up and then down, then up. And then here you can see the same data visualized as a bar chart, and you can see this peak corresponds to this bar here, and same with this peak and this bar. So this is kind of useful. It's nice to see in a single row, but I think it's most useful when you apply it to a whole data set, and you can see how things change over time. It does make some assumptions about how your data is organized, but once you sort of have it in the right order, you can create reports and have some templates where you paste in the new data or you pull in the new data from a database, and then it updates the spark line for you. Perfect. Okay, so create a what if scenario that wherever balls are sold, the volume is double than normal. So what happens when the volume of the balls sold is double? Well, your revenue will go up, your cost will go up. What will happen to your profit? That's a question that you can answer with this what if scenario. So again, you can do more complex things like multiple column what if scenarios. So your costs go up by 10%, your volume goes down by 10%, 20%. What's the scenario? What does your table look like? What does your your forecast look like? Okay. And so I suggest when you do things like that, you have your conditions in a little in cells outside of the table, so you can control them without actually having to manually put them in. You can have references to cells so that you want to you can adjust your what if scenarios using these cell references. All right, so pivot tables. We're going to go through pivot tables pretty quickly. But pivot tables allow you to aggregate and explore large data sets. So if you have like every single entry of every single, so if you have 100 stores and you are selling 50 products in the store, you can have a table where you have for each store every transaction that's occurred in a particular day or month or week. So you can have a list of those transactions, but that's not actually a useful way for you to look at the data, because you want to see perhaps by store, perhaps by time of year or month or day, things like that, or by product even. So those are what, so in those situations you would use a pivot table to take your raw data and pivot it in a way so that you can look at the variable that you're interested in. So for instance here, we can create a pivot table. There's actually already one set up. If you click on quarter pivot, your pivot table is set up so you can see your overall revenue by your month. So January, February, March, and then the sum of the revenue. So maybe you don't want to see everything from each of your products separately, like the way that I had it in the first sheet. You want to see what it is total by month. And you want this table to update when I add new rows to that original data. So you would create a pivot table for month and revenue, and you can also do another pivot table down here that's overall revenue by month, per category, and by product. So these pivot tables are super useful. I use them pretty frequently whenever I use Excel. So when I have Excel, I use pivot tables. So it's kind of handy to see some of this broken out the way you do. To create a pivot table, select your data, and then here you can set the range. So let's say I only want to do A1 to G12. That's what I've got, A1 to G12. You can also use external data sources, CSV files, database connections, things like that. And then once you've selected the pivot table, you'll get a bunch of options. So these pivot table fields, this is where you can specify what fields you want to report on, what the filters are. So the filters are, let's say I only want to have prices on over $50, or my luxury items, I want to filter out anything that's under $50. You can have which columns you want to show up in your final table, what your rows look like, and then also any summary statistics you want, like sum, mean, medians, and things like that. So that's how you create a pivot table. And again, honestly, the best way for you to kind of get experience with pivot tables and learn what they do and how powerful they are is to just try them out. There's only so much I can do by explaining and showing you how to make them. You want to start with the data set, try and ask a question that a pivot table can answer, and then create them yourself, figure out and work with the different options that exist to get it to look exactly the way you want it to. So there's just a few notes in here on how to actually create a particular pivot table. Again, you should go through this yourself so that you can understand what you want it to look like. In the first one here, in the sum overall revenue, in this case, we had our row labels to be the month, and then the aggregate column to be the sum of the revenue. Here we've got the row labels to be the items. So we've got ball, bat, chocolate, and jacket. And then the columns are the months. So here we've got, we've just organized our pivot table in a way so the month is in the column, the rows are product, and the values are just the sum, okay? So this is how you create a pivot table that tries to break out how popular each of your categories are by month. Okay, so here's another thing for you to try. Create a pivot table using the annual sales data that show revenue per month by category and by product. So that previous example kind of, did it aggregately in an aggregate way, and then here you want to do it by month and by category, right? So in the previous example, we had the rows to be individual products, but now I want to have another heading that's a category. So food, chocolate, and toys. And so you can use pivot tables to create these complex structures that let you, at a glance, see what's going on. And perhaps you can then put a spark line here that shows you how popular a particular product is over time. So pivot charts are related to pivot tables. Once you create a pivot table, you can also attach a chart to it. And again, that chart will update anytime your original source data updates as well. And so you can have charts that link to pivot tables. Again, here we've got jacket clothing, and then this is a food category. It's got these lines delineating what the categories are. There's a question in the chat, is this Excel file available somewhere? Yes, it is. So again, on the lecture 4 page of Data 530, if you scroll down just a little bit, it says download the Excel file here. So if you click that download button, it'll download that data for you so you can play with it or work with it live as we go through. Okay, again, you can just create a pivot chart here to do different things. Yeah, I wouldn't worry about this one too much. Creating pivot tables. So there's a question, can you please teach us how to create chart using pivot table? Yes, so why don't I okay, let me do it quickly. So here we have a chart over here. We've got total revenue and then this particular chart here. So once I have this, I can use the insert button here. And then pivot chart is what you want to look for right here. This button here, pivot chart. So once you click that, it should let you create a table as you like it, and then you can fiddle around with it to stack the bars, etc. Hopefully that answers your question. But anyway, creating the pivot chart, creating a pivot table is the tricky part. Once you have the table created, getting the chart is a very natural addition to just adding that. Okay, so we're going to skip this clicker question. I encourage you to read it later and then answer in Slack so that we can just see what the correct answer is. And then I can also report on the final answer in perhaps Piazza. Okay, so GoalSeek is sort of an advanced functionality of Excel. I'm just going to show you what this is. This is not testable material here at GoalSeek. It's just a way for you to solve for particular variables given the target value of another cell. So for example, how many balls would we have to sell in January to have total revenue for the first 3 months of 4,000? And so the answer is 865. Again, this works kind of backwards of a what if scenario. So you can use something like, what would I need my attendant, how many attendants would I need? Sorry, how many attendees would I need at my conference to have a minimum profit amount of $20,000? And then it would sort of calculate that in reverse and give you that answer. So what if scenarios and GoalSeeks go hand in hand, and you can use these together to kind of do predictions and scenario management. So there's some slides in here on how to set up this solver using GoalSeek. All right, more importantly is this analysis tool pack. So the analysis tool pack, I mentioned this earlier, is an Excel add-in that has a set of statistical and data analysis tools such as ANOVAs, covariance, regressions, and t-tests. So this is something that you should install if you don't already have it. On Windows, it's File Options Add-in. On Mac, it's Tools. So again here, where is my cursor? Tools, Excel add-ins. I want to add the analysis toolpack. So when I do this, it'll download a bunch of stuff, install it, and then you'll have some additional functionalities that let you do things like have histograms on a raw data set rather than having to create the bins yourself. So the analysis tool pack is super useful. You'll know it works because when you click the data tab here, you'll be able to see a data analysis button here that exists. So here, again, you can do all sorts of analysis in Excel now. Highly recommend all of you downloading and installing this data analysis. In fact, I think you'll need it for one of the labs, I think. So again, you can do histograms, rank and percentile, regression, t-tests, all sorts of things that normal Excel doesn't have, but this tool pack extends the functionality there. So if you wanted to do a regression and model the relationship between a dependent variable y and an explanatory variable x, we can set up a simple regression, y equals bx plus this epsilon. And then you can do this right in Excel by trying to add this regression line to it. So the technique provides a way to determine patterns in the data set and model the data so that new values can be predicted. You might already know what regression is. So regression in Excel, we want to, let's say we have this plot here of weight versus acceleration. I believe this is of cars, yeah. So car weight and car acceleration. And we want to determine if there's any relationship between them. A scatter plot, when we do it, shows a weak relationship with no strong patterns. However, you can see that these points are all overplotted. So there's a whole clump of points here that are very closely related together, like almost on top of each other, and you're not actually sure whether those are different or not. So this is actually one of the disadvantages of using scatter plots when you have a large data set. You don't actually know whether this is 1 point or this is 10 points, 1 or 10. So you're not sure, because if there's 10 different cars with the exact same weight and the exact same acceleration, they're going to be plotted right on top of each other. And so you don't know whether that single point is 10 different points or 1 point. And that's one of the disadvantages of scatter plots like this. So if we wanted to do a regression, we would go to our analysis tool pack, click the regression button here, and then point it to our data. And then it would give us some additional features that let us set the input range, the output, sorry, the input X and Y, and then where we want the data to be. There's also this feature that lets you do confidence intervals within this regression analysis, and that gives you a sense of how the 95% confidence interval of your data set. And yeah, so residuals also is another nice feature that lets you see how well your data fits that line, and what the difference is between the data point and the line. So that's a measure of residuals. That's available in the regression tool as well. When we do the analysis, we get an output that looks like this. So it's a table. This might be, if you've used MATLAB before or any of the other tools that let you do regressions, you might get some, you might recognize some of these terms: R squared, number of observations, degrees of freedom, F factors, and things like that. So those are all what gets output when you do a regression in Excel. So I would say that, Excel is pretty fully functional for statistics like these. It's only when you have to do more complex algorithms that don't already exist in the tool pack that you might run into some difficulty. And even with those, it's normally someone's done it on the internet, and you just have to find a reliable source that you trust, and then use that sheet to do that type of analysis. Right, so again, here, the output of this regression is that 17.4% of the variation in weight is explained by acceleration. So our eyes did not lie to us. The scatter plot that we showed did show, weak relationship, and the regression analysis confirmed that. Okay, so here is another example of weight versus displacement. I believe that's in one of the sheets below. You can do a regression analysis here and see whether there is an association between weight and displacement, and how much of displacement is explained by it. All right, so in conclusion, I just wanted to summarize everything and say that spreadsheets provide tools for sorting and filtering. So that's a key feature of Excel. You can do some very sophisticated exploratory data analysis just in Excel without even opening a Jupyter Notebook or VS Code to do deep digging. And I would argue Excel is much faster at sorting, filtering, quickly viewing your data, trying to find and identify if there's missing data or what your overall data looks like. Okay, so Excel's super good at that. Pivot tables and charts are useful for aggregating data and displaying your results once you've done that. And the analysis tool pack, super useful for things like creating histograms, doing your statistical analyses in Excel, and also what if scenarios are super useful when you want to model and predict your data. Okay, let's stop it there.